Hello students, in the previous video we had studied matrices. Today we are going to study determinants. Determinants is based on matrices, but what is the main difference is you cannot find the value of a matrix, but you can find the value of a determinant. So it is used in further studies. Watch the video till the end to study determinants from class 12th. What is a determinant? To every square matrix A which has elements of the type Aij of order n, means n rows and columns, we can associate a number, real or complex, called determinant for that square matrix. It is denoted by determinant det of A or mod A, but it is actually not mod A, it is determinant of A. Sometimes it is also written as delta A. That means if I write the matrix as 2 cross 2 matrix having element A, B, C and D, its determinant will be written in the form given over here. And remember one thing, only square matrices have determinants. How to find the value of a determinant? If it has just one row, one column, means a single element, then the value is that element A11. For a 2 cross 2 matrix, 2 rows, 2 columns, having elements A11, A12, A21, A22, the determinant value is A11, A22 minus A12, A21. For example, for the matrix given here, the value of the determinant is minus 6 into 1 minus 3 into minus 1, which is minus 3. Now, evaluating a 3 cross 3 determinant. This is what will be used in the examples. For larger determinants, what we do is there is a process of evaluating the value of the determinant. Any row or column of the matrix is selected. Remember, you can expand the determinant using any row or any column. Each of its elements, say A, R, C, is multiplied by the factor minus 1 raised to R plus C and by the smaller determinant M, R, C, which is formed by deleting the rth row and cth column. Now this you will understand it better with the help of an example. For example, we have the matrix given over here which has 3 rows and 3 columns. So the determinant value for this matrix. Now one more thing, when you are evaluating a determinant, you generally choose the row or column which has maximum number of zeros. If it does not have any zero, fine, you can always expand by the first row, which is very simple. So suppose I want to evaluate this determinant. We can see over here that the second column has maximum number of zeros. So we can choose the second column. Remember, any column or any row you choose, you will be getting the same answer for the determinant. So the first element for the second column is 0. 0 into minus 1 raised to. It is first row, second column. So 1 plus 2, which is 3, into the value of the matrix which you get by deleting that particular first row and that particular first column. So it is 4 minus 1, 1, 7, the value of it. Plus second element is 1 into minus 1 raised to second row, second column is 4. M22 means the matrix obtained by deleting the second row, second column, which is 2, 3, 1, 7. And similarly the last element 0 into minus 1 raised to second row, third column means 2 plus 3, 5 into M3, 2. And the value we obtain thus is 11. We will see examples in which you can see that if you expand the determinant by any row or any column, you will be getting the same answer. Let us now take the first example. You have to evaluate the determinant given over here. Now see, here I have shown by any row or column you evaluate the determinant, you will be getting the same answer. But firstly, what we do is, since the third column has maximum number of zeros, we can choose the third column. So now third column, first element is 4, means it is first row, third column. So it is minus 1 raised to 1 plus 3, which is 4. So it will be just 1. 4 into, you have to take the determinant by eliminating that particular row and column. So 4 lies in the first row and third column. So now the remaining determinant is a 2 cross 2 determinant, minus 1, 3, 4, 1. You know how to find the value of a 2 cross 2 determinant. It is the first diagonal minus the second diagonal, means minus 1 into 1 minus 4 into 3, which is 12. So the first term is 4 into minus 1 minus 12. Second term is minus 0 into, but you know 0 into anything will be just 0. And same way the third term is also 0, so that will also be 0. So the value of the determinant is minus 52. Now suppose if you are having a habit of just expanding by the first row, then also it is fine. Any row or column you choose will be getting the same answer. For example, let us expand it by the first row. First row, first element is 1. So now 1 into, you just take the determinant 2 cross 2 determinant by eliminating the first row, first column. So it is 3 0 1 0. 3 0 1 0, how will you evaluate it? 3 into 0 minus 1 into 0, which is again 0 minus 0. So the first term is 1 into 0 minus 0. Second term for the first row means it is first row, second column. So minus 1 raised to 3, which is minus. Always remember which elements will have minus. The elements in the first row, second column. Second row, first column. Second row, third column, and same way third row, second column. Why? Because their power will be an odd number, so minus 1 raised to any odd number is minus 1. So just if you remember that much, it is fine. So now we are expanding by the first row. So first term is 1 into 0 minus 0. Second term, it is minus 2 into the remaining determinant. Determinant obtained by eliminating the first row and second column is minus 1 0 4 0. So it is minus 1 into 0 minus 0 into 4, which is 0 minus 0. Third term plus 4 into the determinant obtained by eliminating that first row and third column, means it is minus 1 3 4 1. What is the value of that 2 cross 2 determinant? Minus 1 into 1 minus 4 into 3. So it is minus 1 minus 12. Ultimately, the value of the determinant is minus 52. Similarly, you can expand by second row, third row. Let us take one more example. Suppose if we are expanding the same determinant by the first column. First column, first element is 1. Correct? So first row, first column, the power will be minus 1 raised to 2, which is 1. So you don't have to multiply by a negative sign. Negative sign, you just have to multiply, as I told you, first row, second column, second row, first column, second row, third column, and third row, second column. Okay. Expansion by the first column. So first element is 1 into the remaining determinant is 3 into 0 minus 0 into 1, which is 0. Second term will be, second term, remember second term in the first column is minus 1. But since it is second row, first column, you will also have a negative sign outside. So minus of minus 1 into determinant obtained by eliminating the second row, first column, which is 2 4 1 0. So it is 2 into 0 minus 4 into 1. Third element in the first column is 4. 4 into the determinant obtained by eliminating the third row and first column. So that is 2 4 3 0. So it is 2 into 0 minus 4 into 3. So ultimately the value will be minus 52. You expand it by any row or any column, the value of the determinant will always be the same. So there are basically two general practical rules. Either you, if there are zeros, you can consider the row or column which has more number of zeros. Otherwise, keep a habit of expanding by the first row. It will be very easy. Some points to remember. The determinant can be expanded by any row or any column. Correct? Second point is, while expanding, instead of multiplying by minus 1 raised to I plus j, we must just multiply by either plus 1 or minus 1. As I told you, generally you multiply by plus 1, but you multiply by minus 1 for which elements? First row, second column, second row, first column, second row, third column, and third row, second column. If A is equal to sum K into B, where A and B are square matrices of order n, then determinant of A is equal to K into n into determinant of B. Correct? For example, suppose your determinant is 3360 and determinant B is 1120. Correct? Now over here n is equal to 2. Because why n is equal to 2? Because you know it is a 2 cross 2 matrix, and k is equal to 3. Why k is equal to 3? Because you can see over here that matrix A is obtained from matrix B by multiplying each and every element of B by 3. Correct? So now according to our equation, determinant of A should be equal to k into n, means 3 into 2, 6 into determinant of B. Just try to evaluate determinant of A. What is the value? 3 into 0 minus 6 into 3, which is minus 12. Determinant of B, what is the value? 1 into 0 minus 2 into 1, which is minus 2. So determinant of A is equal to 6 times determinant of B. So this is a simple rule for objective questions. Determinants have vast applications. One first easy application is finding the area of a triangle when 3 vertices are given with the help of a determinant. If x1, y1, x2, y2, x3, y3 are 3 vertices of a triangle, then the area enclosed by the triangle you can find with the help of determinant, that is equal to half into the determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. Correct? Now since area is a positive quantity, always remember whether you get positive or negative value, the area you will consider as the absolute value, means the positive value. But suppose if area is given, then you use both positive and negative values of the determinant for calculation. Means area is given, then that area can be based on either positive or negative values. The area of the triangle formed by 3 collinear points is 0. You know that area, if the points are collinear, then the area formed will always be 0. So let us see an example. Find the equation of the line joining A, which has coordinates 1, 3, B, 0, 0 using determinants, and find K if D having coordinates K, 0 is a point such that area of triangle ABD is 3 square units. Now first thing is that you have to find the equation of the line joining 2 points using determinants. Correct? Now suppose there is one more point, say C, which is on line AB. Then A, B and C, all the 3 points will be collinear, but you know when the points are collinear, the area of the triangle is 0 because it will not form a triangle. So by definition of area of the triangle given previously, what is it? Half into x1, y1, 1, x2, y2, 1, x3, y3, 1. x1, y1, either you consider 1, 3 or 0, 0, that is fine. Any point can be taken in any order. So it is 0, 0, 1. Second point is 1, 3, so it is 1, 3, 1. Third point we are considering is xy, so it is xy, 1. So now on simplification of this determinant, it will be half into, remember now we are expanding by the first row. So it is 0, 0 into anything is 0. Second term is again 0, 0 into anything is 0. Third term means first row, third column. First row, third column, so it is 1 into the determinant obtained by eliminating the first row, third column is 1, 3, xy, means y into 1 minus 3 into x. So ultimately half into y minus 3x is equal to 0. This is our equation, and this equation specifies the line joining the given 2 points. When you simplify it, the equation of the line is 3x minus y equal to 0 or y is equal to 3x. So first thing is, given 2 points, considering one more point on that line, we could find the equation, general equation of the line joining these 2 points. Second part of the question says that if there is one more point D which is not on that line, then a triangle will be formed ABD. If the area of that triangle is given to be 3 square units, you need to find the coordinates of that third point D. Suppose the coordinates of D are K0, it is given. So now again apply the formula for area half x1, y1, 1, so 1, 3, 1, x2, y2, 1 means 0, 0, 1. Third point D on the triangle is K0, so K0, 1. This area is given to us as 3. Now remember, as mentioned previously, the area will always be considered positive. So area is given 3, but that means that the value which we are finding could be plus or minus 3, anything. So now since we need to find, that means the value of k which we need to find, for that we have to consider in the reverse process that area is 3 means actually it could be plus or minus 3. Now simplify this determinant. So You can simplify by anything, second row, second column, anything you simplify, it will be getting the same answer. So it is half into minus 1. We are expanding, say, by the second row. So first two terms is 0. Third term will be second row, third column, means minus 1 will be there. So half into minus 1 into the determinant obtained by eliminating the second row, third column, 1, 3, k, 0. So it is 1 into 0 minus 3 into k. That is 0 minus 3k. On simplifying, and this is equal to plus or minus 3. So on simplifying, we can get the value of k, which can be either minus or plus 2. Correct? So the value of k, the point D, could be either 2, 0 or minus 2, 0. Now next important thing, minors and cofactors of determinant. Minor of an element aij of a determinant is the determinant obtained by deleting its ith row and jth column in which it lies, and it is denoted by capital Mij. Minor of an element of a determinant of order n greater than or equal to 2 is a determinant of order n minus 1. That means if you are having a 3 cross 3 determinant, the determinant obtained by eliminating the ith row and jth column would be a 2 cross 2 determinant of order 1 less. Cofactor. Cofactor of an element aij is denoted by capital Aij, and it is defined as capital Aij is equal to minus 1 raised to I plus j into the minor Mij. Correct? If elements of a row or column are multiplied with cofactors of any other row or column, then their sum will always be 0. Remember this. We will see with the help of an example. So for the given determinant, we have to verify that A11 capital A31 plus A12 capital A32 plus A13 capital A33 is equal to 0. So by this example, we will come to know how to find the cofactors. And another thing is just now the result which I said, if you multiply any element, the elements of any row or column, by the cofactors of elements of other row or column, then the sum will be 0. So let us check that also. First is A11. A11 means element in the first row, first column place, which is 2. Capital A31 is the cofactor. How is it obtained? Minus 1 raised to 3 plus 1, which is 4, into minor capital M31. How do you get capital M31? Means it is the determinant obtained by eliminating the third row and first column. So first of all, minus 1 raised to 4 is 1 into M31 means it is the determinant third row first column you are eliminating. So it is the determinant minus 3504. What is that value? 4 into minus 3 minus 0 into 5. So ultimately capital A31 is minus 12. Similarly, A12 element in the first row, second column, that element is minus 3. Multiplied by capital A32 means the cofactor. It is equal to minus 1 raised to 3 plus 2, which is 5. So ultimately minus 1 raised to 5 means you have to multiply by a negative sign. Into M32. M32 is the determinant obtained by eliminating the third row, second column. Correct? So which is the determinant? Third row, second column we will eliminate. So it is 2, 5, 6, 4. What is the value? 2 into 4 minus 6 into 5. So A32 is 22. Similarly A13 and M33. So now when you verify, the left hand side value is 0. Now the adjoint of a matrix. The adjoint of a square matrix having n rows and columns is defined as the transpose of the matrix Aij, where Aij is the cofactor of element Aij. Adjoint of the matrix A is denoted by Adj of A. First of all, what is transpose of a matrix? Transpose of a matrix means when you interchange the rows and columns of a matrix, you get its transpose. Correct? Now this will understand better how to find the adjoint with the help of an example. First of all, some definition. A square matrix is said to be singular if the determinant is 0 and it is non-singular if the determinant is not equal to 0. So there are now some theorems. We just accept them without proof. If A is any given square matrix of order n, then A into adjoint of A is same as adjoint of A into A, which is equal to determinant of A into I, where I is the identity matrix. If A and B are non-singular matrices of the same order, then AB and BA are also non-singular of the same order. The determinant of the product of matrices is equal to the product of the respective determinants. Means determinant of A into B is equal to determinant of A into determinant of B. So let us understand how to find the adjoint of a matrix. First of all, in general notation, if you consider a 3 cross 3 matrix, it will have the following elements. So adjoint of A is the transpose of the matrix of cofactors. Just now we have seen how to obtain the cofactors. So cofactors, if I consider it, they are denoted by capital A11, A12 and so on. Its transpose means the row will be converted to the column. First row will become first column, second row second column, third row third column. So ultimately adjoint of A is capital A11, A21, A31. That will be the first row for adjoint. Remember. A12, A22, A32, that will be the second row for the adjoint, and capital A13, A23, A33 will be the third row for the adjoint. For example, first of all, a simple example of a 2 cross 2 matrix given over here, you will have to find the adjoint. So first thing is to find the adjoint, find the cofactors. Correct? Cofactors. Now A11 means it is first row, first column. So minus 1 raised to 2, which is 1. So you don't need to multiply by a negative sign. For a 2 cross 2 matrix, if you eliminate the first row and first column, you will just remain with one element, which is 4. So A11 is 4. A12 means first of all, the minus 1 raised to 2 plus 1, 3 means you have to multiply by a negative sign. If you eliminate the first row and second column, which element is remaining? 1. So it will be minus of that 1. A21. Again A21 means you have to first multiply by a negative sign. Eliminate the second row first column. So remaining element is 3. So A21, capital A21 is minus 3. A22, 1 into eliminate second row second column, element is 2. So these are our cofactors. Remember, for adjoint of A, you have to take the transpose of matrix formed by cofactors. So now A11, A21. Remember, A21 will be coming in the first row because you are interchanging the rows and columns. So write the respective elements A11, A21, A12, A22. So the adjoint of A is 4, minus 3, minus 1, 2. Now the next important thing is finding the inverse of a matrix. If AB is equal to BA and both of them are equal to the identity matrix I, then we say that B is the inverse of A. It is also written as A raised to minus 1 and it is called A inverse. So A inverse is B and B inverse is A. Also, if you take the inverse of A inverse, it is the original matrix A. Now to find the A inverse, how do we find it? A inverse is equal to adjoint of A upon determinant of A. So for example, let us take a simple 2 cross 2 matrix which has elements 2, 3, 1, 4. Okay. First of all, what is the determinant of A? 4 into 2 minus 3 into 1 means 5. Okay. Now how to find the adjoint? Adjoint means first you take the matrix of cofactors and then you take the transpose of that matrix of cofactors. So the matrix of cofactors is, for a 2 cross 2 matrix, as I told you, you just have to eliminate that particular row and column. So only one element will be left over. And that one element you have to write with the corresponding sign. If the total of row and column is odd, the sign will be minus. If the total of row and column is even, the sign will be plus. So the first element in the matrix of cofactors will be eliminate the first row, first column. So 4. Second element in the first row, it will be eliminate the first row, second column. So the element is 1. But since it is first row, second column, you will have a minus sign outside. So minus 1. Same way, second row, first column. When you eliminate both of them, the element is 3, but it will be with a minus sign. So minus 3. And second row, second column element, the element is 2. So the matrix of cofactors is 4, minus 1, minus 3, 2. Adjoint is the transpose of this matrix. Transpose means when you interchange the row and column. So it will be 4, minus 3, 1 and 2. Sorry, minus 1 and 2. Now what will be A inverse? A inverse is adjoint upon determinant of A. So it is 4 minus 3 minus 1 2 into 1 upon 5. So this is how you find the inverse of a 2 cross 2 matrix. Similarly, we will see for a 3 cross 3 matrix. Before going to the examples, an important theorem. A square matrix A is invertible if and only if A is a non-singular matrix. Non-singular matrix means determinant should not be equal to 0 and invertible means inverse exists. So first of all, let A be an invertible matrix of order n and I is the identity matrix of the same order. Since it is invertible, inverse exists, so let B be the inverse of A. So by definition, A into B will be B into A and both will be equal to I. Now A into B is I. So determinant of AB is determinant of I. And you know that determinant of I is 1. Correct? So what we have is determinant of A into B is same as determinant of A into determinant of B. So what we have is determinant of A into determinant of B is equal to 1. So this shows that determinant of A cannot be 0 in any case. Hence we have shown that A is non-singular. So first part, we took a invertible matrix and showed that it is non-singular. Second part, conversely, let A be non-singular means determinant of A is not equal to 0. And we will prove that inverse exists. Now A into adjoint of A is same as adjoint of A into A and both are equal to determinant of A into I. This is by the first theorem which we have seen. So now what we have is A into adjoint of A upon determinant of A is same as again adjoint of A upon determinant of A into A. Just we have taken the determinant of A in the denominator. Correct? Now A into B is equal to B into A is equal to I. If this condition is satisfied for any two matrices A and B, then we say that both are inverses of each other. So here what we have is, we have a matrix A and then we have a whole matrix which is adjoint of A upon determinant of A. Suppose that is some matrix B. So what we have shown is A into B is equal to B into A and they both are equal to I. So we have shown that inverse of A exists, that means A is invertible. Now take the next example in which we will come to know how to find the inverse of a matrix of order 3 cross 3. So you have to find the inverse of the given 3 cross 3 matrix. First of all, we have to check whether determinant of A is not equal to 0. Only then A inverse will exist. So first we find the determinant of A. Again I am telling you, we can expand the determinant by any row or column. Correct? Basically you know that the second row or you can see the third column, both are having 1 0. So you can consider that for easy calculation. So suppose if I am expanding by the second row, so it is 4, but 4 is second row and first column, means minus 1 raised to 2 plus 1, which is minus 1. So you have to add 1, you have to multiply 4 by minus sign. So minus 4 into the remaining determinant. Remaining determinant means determinant obtained by eliminating the second row first column. So it is 1 into 1 minus 3 into 2, which is 6. Second term is minus 1. Minus 1 into eliminate the second row second column. So 2 into 1 minus 7 into 3. So when you simplify that, the value of the determinant is minus 3, which is not equal to 0. But see, if any time 0 is not given, or if you want to make it simple, you can always expand by the first row. Correct? So if you expand by the first row, then 2 into minus 1 into 1 minus 0. Second term will have a minus sign. So minus 1 into 4 into 1 minus 0. Third term is plus 3 into 8 minus 8 minus 7 into minus 1. So 8 minus 7. So ultimately again you are getting minus 3. Determinant of A is not equal to 0. Now second thing is, for finding the inverse you have to find the adjoint. For finding the adjoint, you have to find the matrix of the cofactors and then take the transpose of it. So now A11 means when you eliminate the first row, first column and you multiply by that cofactor, you will get A11. Okay. So when you eliminate first row, first column and evaluate the remaining determinant, it is -1 into 1 minus 0 into 2, which is -1. A12, now since it is 1 plus 2, a negative sign will be there first of all. So A12 will be minus into minus 1, sorry, minus into 1 into the determinant obtained by eliminating the first row, second column. So it is 4 into 1 minus 7 into 0. So it is 4. So A12 is minus 4. A13, it is 4 into 2, which is 8, minus 7 into minus 1. So it is 1. Now second row, first column. Since it is the first example, let us understand it for each row and column. So A21 means second row, first column. Second row, first column means first of all you will have a minus sign outside. Correct? Now when you eliminate the second row, first column, and remaining determinant will be 1 into 1 minus 2 into 3. So A21 will be minus of 1 minus 6, which is 5. A22, it will be 2 into 1 minus 7 into 3. So that is 23. A23 again, since 2 plus 3 is odd number, so you have a minus sign outside. Eliminate the second row and the third column. Remaining determinant 2 into 2 minus 7 into 1. So A23 is minus 11. Similarly A31, A32 and A33. Now remember, when you find the adjoint of A, you have to take the transpose of the matrix of cofactors. So directly, when you are now onwards, directly you can write adjoint of A. Instead of A11, A12, A13, the first row will be A11, A21, A31, since we are taking the transpose. Similarly, the second row of adjoint of A will be A12, A22, A32. And the third row will be A13, A23, A33. So from the above elements, just directly write the elements. You are getting the adjoint. A inverse is adjoint of A upon determinant of A. So 1 upon minus 3 into adjoint of A. Or if you want to take the minus sign inside, it is 1 upon 3 into 1 minus 5 minus 3, 4 minus 23 minus 12, minus 1, 11 and 6. Okay. So this is A inverse. Now see, we have found the inverse of the given matrix A. In case in exam you want to verify whether your answer is right or wrong. So if you have time, you can always verify this. A into A inverse should be equal to I if your A inverse is proper. So I have taken over here, multiplied A by A inverse. Taking 1 upon 3 outside, just multiply the two matrices. You know how to multiply. For getting the first row, first column, multiply first row by the elements of first column, means 2 into 1 plus 1 into 4 plus 3 into minus 1. For getting the element in the first row, second column, take the first row of the first matrix and the second column of the second matrix. So 2 into minus 5 plus 1 into minus 3 and plus 3 into 11. Okay, this is how we multiply two matrices. When you simplify this, you get the identity matrix. So our answer is correct. Next, find the inverse of the given matrix. Now here, first of all, find determinant of A. Determinant of A is 1 into cos alpha into minus cos alpha minus sin alpha into sin alpha. So it is minus 1, which is not equal to 0, since sin square plus cos square is 1. So determinant of A is minus 1, which is not equal to 0. So A inverse exists. Now same procedure, find the matrix of the, first of all find all the cofactors. So A11 means you have to eliminate first row, first column. So it is minus cos square minus sin square, which is minus 1. Many other elements, since the matrix has 0, so many other cofactors will be 0. Now adjoint of A, as I told you, directly write A11, A21, A31 in the first row. Instead of first column, it will become the first row, and similarly other rows. So adjoint of A, we have found out A inverse is adjoint of A upon determinant of A. So you can write it as 1, 0, 0, 0 cos alpha sin alpha, 0 sin alpha minus cos alpha. This is A inverse. And I have again verified over here so that we can check our answer is right or wrong. We get A into A inverse is equal to I. So our answer of A inverse is correct. Example 5. If A is the given matrix, you have to verify A cube minus 6A square plus 9A minus 4I is equal to 0 and hence find A inverse. Here 0 is the 0 matrix, remember. Now see, A is equal to 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. So first thing to verify this, you need to find A cube A square. First of all, we find A square, multiply A by A. Take care while doing the calculations, correct? So we have found, you know how to multiply two matrices, first row first column, then first row second column, first row third column, and so on. So after multiplication we get A inverse. For A cube you can either do A dot A square or A square dot A. When you again multiply these two matrices you get A cube. Now just put the values. Left hand side is A cube minus 6 into A square. So directly I have multiplied 6 by each and every element of A square. Plus 9 into each and every element of A. Minus 4 into the identity matrix. So identity matrix has diagonal elements 1. You multiply it by 4. So you get as 4 0 0 0 4 0 0 0 4. Now when you do the calculations you get that equal to 0. So you get the 0 matrix. Correct. So we have verified that A cube minus 6A square plus 9A minus 4I is equal to 0. Next part of the question, using this we have to find A inverse. Correct. Now first of all we have the given equation. You multiply the given equation on both the sides, pre-multiply by A inverse. So first term will be A inverse into A cube. That you can write it as A inverse into A square. Similarly, second term will be minus 6 into A inverse into A square. You can write that as minus 6 into A inverse into A dot A. Similarly, third term 9 into A inverse dot A, and the right hand side will be 4 into A inverse dot I. Now, A inverse dot I is A inverse dot A is I. So, first term will be I into A square, that is A square. Second term will be minus 6I into A, that is minus 6A plus 9I. So now A inverse is 1 upon 4 A square minus 6A plus 9I. So now you just have the values of A square, A and I, you know. So you just put the values for the matrix A square and A. Do the simplification, you will be getting A inverse as 1 upon 4 into the matrix 3 1 minus 1 1 3 1 minus 1 1 3. You can always verify the answer. Now see, we have seen one of the applications of determinants. It was to find the area of a triangle or to see whether the points are collinear or not. Second very important application of matrices and determinant is solving a system of linear equations. Correct? System of linear equations means, first of all, you can have a system which is either consistent or inconsistent. Consistent means a system of equations is said to be consistent if its solution, say one solution, unique solution or more solution exist. Inconsistent means it does not have any solution. Now what is this actually? See, for example, I have this, the sum of three numbers is 6. If we multiply third number by 3 and add second number to it, we get 11. By adding first and third numbers, we get double of the second number. Correct? So now if I want to express this in the form of linear equations, I can say let first, second and third numbers be denoted by x, y and z respectively. So how can I write? Sum of numbers is 6, means x plus y plus z is 6. Multiply third number by 3 and add to second number. So y plus 3z, that is 11. And the third case is by adding first and third numbers, we get double of second, means x plus z is 2y or x minus 2y plus z is 0. So now we are having three unknowns and three linear equations. How to solve it using the matrix or the determinant method? Correct? This is what we are going to study. So first thing is very simply how I can write this is in the form of matrix form. Let A be the matrix in which you are having the coefficients of all x, y and z in all the three equations. So first equation, coefficient of x, y and z are 1, 1, 1. So first row is 1, 1, 1. Second equation, since x is not there, it is 0. Y plus 3z means 1, 3. Third equation, x minus 2y plus z means 1 minus 2, 1. I can write the matrix X, capital X, as having the elements small x, y and z, and I can write the matrix B is equal to the right hand side, which is 6, 11 and 0. Now remember, if you multiply A into X, just multiply it, what will you get? X plus Y plus Z, first equation. Second row will give you 0 into x plus 1 into y plus 3 into z, means y plus 3z, and similarly x minus 2y plus z, and that is equal to the right hand side, which is the matrix B. So very simply we have just written the three equation in the matrix form. Let us see how to solve it. Before knowing how to solve the system, let us first of all write it in general form. Remember, in general form means if you are having any square matrix, and you can definitely solve it using this method. So suppose I am having n linear equations in n variables, I can express in the form of A into x equal to B, where matrix A is the matrix of coefficients, X is the column matrix of all the variables, and B is the column matrix of all the constants on the right hand side. So this is how we can express in general form AX is equal to B. So how are we going to solve this? First of all, A has to be a non-singular matrix, means the determinant of A should not be equal to 0. And if this is the case, you know its inverse exists. So now what was our equation? AX is equal to B. Pre-multiply both the side by A inverse. So A inverse into A into X is equal to A inverse into B. A inverse into A is I. So and I into X is X. So what we have obtained is X is equal to A inverse into B. So remember, X is our column matrix of the unknowns. You know A, you know B. So you can find X is equal to A inverse into B. So this is how you find the unknown variables. This matrix equation provides unique solution for the given system of equations. This method is called the matrix method or inverse matrix method. Now, which cases may arise? First of all, if A is a singular matrix, then what will happen is determinant of A will be equal to 0. So in this case, we calculate adjoint of A into B. If adjoint of A into B is not equal to 0, then the system will have no solution, hence it will be inconsistent. It will be inconsistent because adjoint of A into B will not be equal to 0. Correct? Second case, if adjoint of A into B equal to 0, adjoint of A into B equal to 0, then the system may be consistent but with an infinite number of solution, or it can be inconsistent with no solution. So two cases may arise in this. Either the system may be consistent with an infinite number of solutions, or it will not have any solution itself. Okay. But if the determinant of A is not equal to 0, then it will have a unique solution. Let us see the example which we had just discussed, how to solve that. The example we have just seen had these three equations, if you remember, and we could express it in the form of AX is equal to B. Let us see how to solve it. So our equation is X is equal to A inverse into B. A is 1, 1, 1, 0, 1, 3, 1, minus 2, 1. First thing is check for determinant of A. Determinant of A is 9, which is not equal to 0, so unique solution exists. Now you find the matrix of cofactors first of all, and then take transpose to get the adjoint of A. Basically first you find all the cofactors A11, A12 and so on. So now A11, A12, A13, all this when you have found, adjoint of A means, remember you are taking transpose. So A11, A21, A31, that will come in the first row instead of column. Similarly other elements will be there. So adjoint of A you have found, A inverse is 1 upon 9 into that adjoint of A. So what is X? X is A inverse into B. So first write the matrix A inverse, then write the matrix B. B is 6, 11, 0. Column matrix 6, 11, 0. And why can you multiply it? Let us revise. As we have seen, first matrix is of order 3 cross 3, second is 3 cross 1. So your resultant matrix when you multiply will be of the order 3 cross 1, means 3 rows 1 column. So when you multiply both of them, you get 1 upon 9 into the matrix having column matrix having elements 9, 18, 27. So ultimately x is 1, 2 and 3. X is 1, small x is 1, small y is 2, small z is 3. So our variables, we have got the value of all the 3 variables. Next problem. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60. Cost for 2 kg onion, 4 kg wheat, 6 kg rice rupees 90 and 6 kg onion, 2 kg wheat, 3 kg rice is 70. Find the cost of each item per kg by the matrix method. So first of all, let us assume that the cost of onion, wheat and rice is rupees x, y and z per kg respectively. First form the 3 equations. So we have formed the 3 equations. Now the 3 equations you can keep it as it is, but in the second equation you can see that 2 is coming out. So to make the calculations easy, from all the 4 terms you take out 2 commons. It will be x plus 2y plus 3z is equal to 45. Correct? This is just for simplification in calculation. So now we have got the matrix A, which is a matrix of coefficients 4, 3, 2, 1, 2, 3, 6, 2, 3. X, y and z. B is the column matrix of right hand side 60, 45 and 70. X is equal to A inverse of B. So first of all check A inverse. First of all check determinant of A. Determinant of A is 25, means not equal to 0. Your A inverse exists, you will get a unique solution. So now using the matrix method we will find the solution. X is equal to A inverse into B. So first find A inverse. Again find the matrix of cofactors, adjoint of A. You just take the transpose of the matrix of cofactors. So first row will be having A11, A21 and A31, these 3 elements, these 3 cofactors. Similarly other rows and columns. A inverse is adjoint of A upon determinant of A. So A inverse is 1 upon 25 into adjoint of A, but 5 is common everywhere, so you can write A inverse as 1 upon 5 into 0 minus 1 1, 3 0 minus 2 minus 2 2 1. Now x is equal to A inverse into B, so just multiply this A inverse into our matrix B. So when you do the simplification you will get that as 1 upon 5 into the matrix 25, 40, 40, or it is divide by 5 each element, so it is 5, 8, 8. Hence, small x is 5, small y is 8, small z is 8. That means the cost of onion per kg is rupees 5, cost of wheat per kg is rupees 8 and cost of rice per kg is also rupees 8. Example 8. We have seen that A into B whole inverse is B inverse into A inverse. Correct? So, we will verify this for the given matrices. You are having 2 cross 2 matrices. First of all, it's a simple thing. First of all, multiply A into B. So, the matrix A into B will have the elements 67, 87, 47, 61. Now, you find the inverse of this matrix A into B. So, you find the inverse of the given matrix. 1 upon determinant of A. Determinant of the given matrix. Determinant of the given matrix is 67 into 61 minus 47 into 87. So, when you simplify this, you will be getting minus 2. So 1 upon minus 2 into adjoint of this matrix. Now remember, for 2 cross 2 matrix it is very easy to find the adjoint. You just eliminate that row and column and the remaining element you write, but take care of the sign. Correct? So for the first row second column and second row first column you will have to multiply by a negative sign. So now AB whole inverse is 1 upon minus 2 into adjoint. For this adjoint, first row first column when you take out, only remaining element is 61. First row second column when you take out, the remaining element is 47 but with a minus sign, so minus 47. Remember, for adjoint it is the transpose of the matrix of cofactors. So for the cofactor which is in the first row second column, that will go in the second row first column. So AB inverse is 1 upon minus 2, 61, minus 87, minus 47 and 67. Check it out. Now individually find A inverse and B inverse. So right hand side is B inverse into A inverse. So multiply B inverse into A inverse and simplify it. When you simplify it, you will be getting AB whole inverse. So we have verified that AB whole inverse is B inverse into A inverse. Next example, you have to solve the given system of linear equation by the matrix method. So only difference is over here, you are having 2 upon x plus 3 upon y plus 10 upon z equal to 4. So you just consider first of all 1 upon x as some other variable a, 1 upon y is b, and 1 upon z is some variable c. So now accordingly we will be getting the new set of equations, 2a plus 3b plus 10c equal to 4, 4a minus 6b plus 5c equal to 1, and 6a plus 9b minus 20c equal to 2. Now use our matrix method. So you have the matrix A, you have the matrix X and the matrix B, which is the right hand side. X is equal to A inverse into B. First of all, determinant of A is 1, 2, 0, 0, which is not equal to 0. So you will get the solution. Find the matrix of cofactors, find adjoint of A, find A inverse. So that is the first step. So when you do the calculations, you will get A inverse is equal to 1 upon 1, 2, 0, 0 into the matrix 75, 150, 75, 110 minus 130, 72, 0 minus 24. Next step is multiply this A inverse by B. So X is A inverse into B, multiply A inverse by B, simplify it, you will get the value of small a, b and c as half, 1 upon 3, 1 upon 5. But A is 1 upon x, b is 1 upon y, c is 1 upon z. So we have got the solution, x is 2, y is 3 and z is 5. Now some objective questions. I have given the objective questions and also the answers for the same. In case of any query, please write in the comment section. Hope determinants is understood. Do like and share the video and subscribe to the channel for maths of class 9, 10, 11 and 12.